For as long as there has been fire, humans have sought better ways of putting fire out. Through most of history, firefighting was as simple as carrying water to a fire. But as information processing and storage became more valuable than the property that held it, water ultimately could destroy more than it protected. As an answer to this problem, fluorinated halon gases were developed. They were low in toxicity and highly effective. Amazingly, they put out the fire, but the electronic equipment kept running unaffected. By the early 1980s, halons were in common use on aircraft and ships as well as in computer facilities and galleries. But by 1993, they were substantially banned by the Montreal Protocol because of their pernicious depletion of the ozone. How serious was the problem? Charting ozone depletion on the horizontal axis and using the size of the dot to represent atmospheric lifetime, it's clear that Halon 1301 had serious problems. And while Halon 1211 was an improvement, it still was unacceptable, and Halon was phased out. Scientists quickly began working to create alternatives that would be as effective as halon, but without halon's negative environmental effect. The most widely accepted alternative initially was a group of chemicals called hydrofluorocarbons. HFCs extinguished fire to a large extent like halon, but didn't deplete the ozone layer. But in the late 1990s, as concern about climate change grew, the Kyoto Protocol addressed the heightened concern for emissions of greenhouse gases, including HFCs. The concern was well justified because a 320 kilogram HFC fire system has a global warming impact equivalent to the emissions of 241 cars driven for a year, 6 railroad cars if coal burned, or over 1 million kilograms of carbon dioxide emitted. When we add global warming to the vertical axis of our chart, the problem with HFCs becomes clear. So, once again, technology and industry were faced with a short-term solution that turned out to be too damaging for the environment. This increased regulation and concern for the environment led 3M scientists to develop the extinguishing agent that would ultimately become Novec 1230 fluid. It would need to be highly effective at extinguishing fires, safe for valuable assets, have low toxicity, have zero ozone depletion potential, have a short atmospheric lifetime, and have a negligible impact on global warming. They sought to create an extinguishing agent that would not only meet all current regulations, but those in the future regulatory framework established to address the growing challenge of global climate change. Hundreds of alternatives were considered, but did not meet these stringent requirements, until finally a rather unusual compound was considered, C6-fluoroketone. Previously, this class of chemicals was thought to be unsuitable because fluoroketones generally don't have the safety profile required for fire protection. But amazingly, it proved to be the answer the world was looking for. C6-fluoroketone balances the need for a material that leaves no residue, meets clean extinguishing agent fire protection standards, dramatically reduces the impact on the environment, and has the largest margin of safety of any commercially available clean agent. 3M named it Novec 1230 fluid. Novec 1230 fluid has distinct advantages over its predecessors because its weight and fluidity make it easier to refill and systems don't require large amounts of space. Here's how Novec 1230 fluid works. It starts as a liquid so that it can be easily transported, making filling and refilling discharge systems so much easier than conventional gaseous agents. But when dispersed with a super pressurized nitrogen system or other method, its unique properties allow it to quickly become a gas. In fact, it evaporates 50 times faster than water. So just how much of an environmental improvement is Novec 1230 fluid over compounds used in the past? Here is Novec 1230 fluid compared to halons and HFCs. Did you miss it? Here, take a closer look. Novec 1230 fluid has a global warming potential of just 1 and no ozone depletion potential. Here's a demonstration of Novec 1230 fluid in action. A fire begins in a computer room. Within 10 seconds, the fire alarm sounds. Soon after, the room is flooded with Novec 1230 fluid, and within seconds, the fire is out. And most importantly, the unaffected equipment continues to run because it has virtually no effect on the operation of electronic equipment. For example, this monitor is running in a tank of Novec 1230 fluid. Novec 1230 fluid has proven to be a remarkable solution for a wide range of industries that are committed to choosing a responsible fire protection solution. So now, with Novec 1230 fluid, you can protect your equipment, your operations, your data, and most importantly, your people. All with an environmentally sustainable technology. 3M Novec 1230 Fire Protection Fluid, created for life.